Hi there, are you tired of your old sauce being barbecue sauce? We have the product for you, as we like to call it, the mathematical sauce.
Question 1, determine whether each question is if it's biased or not. Remember, bias just means does it lean towards one, help you push you in a bad way towards one or the other. Question number 1, would you like to have a really tasty cupcake or a slice of pie for dessert? Well, maybe you're a waitress and waiter or waitress trying to make more money on tips, but I think that's a little bit biased, right? They're trying to sell me on something that's very tasty. Question 2, where do you attend elementary school? This to me is unbiased. Remember, unbiased means it's a fact question, right? No emotions, no emotions. Number 2, feedback. Chandra writes a blog and would like to receive feedback from the readers who have an email subscription. All right, I'm going to underline that one. Email subscription. She sends a questionnaire in Monday's email and asks the responders to respond. It's classifying the method. Okay, she did not break up her readers. You know, in her readers list, she's not saying every 5th person, so that would be systematic. I have self-selected and convenience. So convenience would be what is easiest for Chandra. She could just say the first 10 people on her readers list. But here, this is self-selected because she's just going to email them, and the readers who respond, right? There's our keyword, so our answer is going to be self-selected. Match each study with a study type being used. Remember, observational study is just whatever you observe. Experiment is something you do to them, and a survey means you give them or you ask or you give them something. Okay. 3A. To determine whether the patrons of a local fitness center like new exercise equipment, the owner asks a random sample for their opinions. So if you're just asking someone for their opinion, they're just going to give you their opinion, right? So that would be A. This one is A. A florist, let's write that, giving their opinion about gym equipment. Okay. B. A florist is testing a new plant food that should allow fresh cut flowers to last longer. She randomly selects half the cut flowers and applies the plant food and records the results. So she's doing something. She's only giving half the flowers this new plant food. So she's giving or doing. That would be B. Florist gives new plant food. And that's why it's an experiment. She wants to compare, right? Does that stuff actually work? Okay. C. Researcher observes toddlers playing with a newly developed toy and record the reaction. So they're just watching. So that would be C. Watching toddlers to see reaction. Keyword there is watching or observing. A random number generator was used to select a number from 1 to 8. A number was selected 120 times and the results are shown. Complete the statement below, round to the nearest 1/10% if possible. Okay, so the theoretical is if you have 8 numbers. Remember, theoretical is just what should happen. It's select over the all. So if you're trying to select a 7, there's only one 7 over how many numbers? 8. And so if you divide those, you will get 0.125, and then multiply by 100, you will get 12.5%. So 12.5% is our answer. Number 9, calculate the mean and standard deviation for the dataset, round to the nearest 10th if necessary. Okay, so I'm going to take those numbers, and if you have your phone or graphing calculator, I'm just going to punch those in. So the calculator commands are stat, edit, go to the top of your list, press clear, and then clear, then enter, then they go away. Okay, let's go ahead and input all those numbers: 16, 18, 23, 17, 15, 22, 21, 19, 26, 17, 14, and 18. I'm going to press stat, calc, one-var stats, and it's already on list 1, so that's the default, which means you don't have to press it, so you can just press enter. And here the X bar is 18.9, and then the standard deviation here, double checking I have my numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Uh-oh, I only have 11 numbers. Oops, I did it again. 16, 18, 23, 17, 15, 22, 21, 19, 26, 17, 14, and I forgot the last one. Stat, calc, one-var stats. Okay, X bar is 18.8, and our standard deviation there looks like SOCS is, because we have all the numbers, it's not taken from a sample, so it's not SX, that would be a sample. So this would be 3.38 or 3.39. Let's write that. So that was X bar, and this one was the population. Standard deviation, again, because you have all of the numbers. This does not come from a sample. Like if I had a class of 40 students and then I say, how many M&Ms can you eat in 20 seconds, right? Without choking or something. Spelling. Miss Karuma gave a spelling test to her second and third period Spanish classes. There were 20 words given, and a number of correctly spelled words are shown in the tables. The average score is higher for which period? So average score again is your average. And then the scores were more varied. Varied means variation. And that would be our standard deviation. So I'm going to go ahead and put in both those lists. We'll call this one list 1 and this one list 2. And there are 16 students in each class. So let's just put this like a chart. And I'm going to have the average, should be actually the mean of that one. Because you have the whole population of the class, and then the standard deviation. All right, let's go ahead and pump in these numbers into the list. Clear, stat, edit, list 1. I'm going to press clear, enter, and then every number I'm just going to press 20, enter, 10, enter, 20, 15, 18, 18, 19, 20, 14, 17, 18, 19, 16, 14, 16, and 14. I'm going to go up to list 2. I'm going to press clear, then enter, and then enter those numbers for period 3. I'm going across 19, 8, 20, 10, 12, 17, 20, 16, 18, 16, 18, 18, 17, 14, 12, and 19. So I'm going to press stat, calc, one var stats. Remember, if I press enter, this is the average. I'm sorry, this is for period 2, so 16.75. Write that down, 16.75 and 2.73. Okay, so I got that information down, and then I'm going to press stat calc one var stats, and then I'm going to put in list 2. So that'd be second, number 2, second, number 2. And this would be a 15.88 in the SOCS, which is your population standard deviation 3.53. Okay, so if I go back, whoops, wrong one. And 16.75, 15.88, 2.73, and 3.53. All right, so which one had a average that was higher? That would be 16.75, so that would be period 2. And then which one has more variation or higher variation? A higher variation just means a higher, and this would be period 3. Distance ran in 30 seconds. Well, that one would be continuous because you can get like 37.6 feet. You can go 41.9 feet or 50.0 feet. Total snowfall in a city each winter, you can do fractions or decimals, and that would be continuous. Hey guys, let's go over this question about standard deviation and mean. The test scores from students in the physics class are shown 76. So that's my first, second, third, fourth, fifth number. Find the mean. The mean is taking the numbers and getting a summation, the total. So if you add all these numbers up, 76 plus 94 plus 82 plus 77 plus 84 divided by, there's 5 numbers, that's what the n is. You'll get 416 over 5, and that'll give you 82.6. Okay, so now we're going to calculate standard deviation by hand. So x, let me write down the formula. Standard deviation is the square root of the summation of all your numbers subtracted by the mean squared divided by n, and the n is in the square root. So the data points, the first number is 76, second number 94, x3, the I becomes the number in the list, so this would be 82, x4 is 77, x5 is 84. Okay, next we're going to take the value, and now we're going to subtract it by this number here. The x bar. So the x bar is 82.6. And so I have all of these numbers. Let's do some magic. Okay, close enough. Okay, when you subtract those values, you will get negative 6.6, 11.4, negative 0.6, negative 5.6, and then 1.4. The common mistake for students, because they didn't write down the formula, is you take the value, so right here in red, and then you're going to square the value. So you have to use parentheses. So you're taking the data point subtracted from the mean and you're squaring it. Okay, when you do that, you will get 4356. And here, that's when I rounded to the nearest hundredth, 2 decimal places just to make it easier. Okay, if you look back at your formula, we've done all these things. Now we're going to do the summation. So if you add up all of these values, add them up, you will get 207.2. Okay, you can do 2 things here. You can, what I did is I just took this value and divided by n. So, when you do 207.2 divided by 5, that in green gives me 41.44. And I still need to take the square root. When I take the square root of that number, I will get 6.437, and then it did tell us to round to the nearest 10th. So looking at this number, what does that become? It stays. So my answer is the standard deviation is 6.4, and the mean is 82.6. A normal distribution has a mean of 24.8 and a standard deviation of 1.6. Find the range of values that represent the outer 5%. Okay, for this one, I'm going to have to use they want to know X values. They want to know the value on the picture. So this, I want to list out though, that this is not a percentage. You're not finding a percentage. So let's do the same thing we did. Let's go ahead, and the first thing I'm going to do is I'm going to draw a picture. Here's my normal curve. Okay, so when it says find the range of values that represent the outer 5%. To me, that means that this is 5%, or in a decimal 0.05, and this represents 0.05. Let me think about that. Nope, I'm gonna take that back. I think 5% means 2.5% plus 2.5%. And 0.025 is, this region over here. And why I say that is because if you add those together, you get what? This represents 5%. So 100 minus 5% will give us 95%. And then this number is going back to our normal distribution, which is our already listed amount above is our empirical rule, which is the 68, 95, 99.7. Does this make sense? And the big idea in this one is this is 1 standard deviation, 2 standard deviations, 3 standard deviations away. So let's try to color code this so you can see this. The mean is a measure of center. So I put that right in the middle. So the mean is 24.8. Does that look like a 24? 24.8. Kobe, double Kobe, sorry. And, okay, so, whoa. What happened to Kobe? Okay, now the standard deviation of 1.6 just basically means we need to add 1.6. That would give me here. And then we add it again, would give me there. And you would subtract 1.6. Okay, how did I know to do that? Well, remember, this is 1 standard deviation away, and this is another standard deviation away. So that first orange mark right here with my black dot, that represents one standard deviation. This one, you go count 1, 2. This green dot here represents 2 standard deviations away. Okay, so let's just add. Let's just add here 24.8 plus 1.6. This gives me 26.4. So basically you're just adding 3.2 to 24.8. And that'll give us 28. Okay? All right, let's go the other direction. Pick a different color. So now this is 1 standard deviation away, 2 standard deviations away. So I really need 24.8 minus 1.6 minus 1.6. And this would give us 21.6. And those are the 2 numbers that I needed. So the x value, they're saying under the distribution, has to be, if you want the outer 5%, you have to be a number less than 21.6. And this one would be a number greater than 28 to get the yellow shaded region. So tricky question, but that's what it means there. It says, what is the value of z? So that means they're asking z is equal to what? If you know the x, standard deviation, and the mean. So the formula, if you look back, z equals x minus the mean over the standard deviation. And you just substitute in these values. So x goes there. .6 minus our standard deviation is 2.8, and then the mean is 9.2. So if you put that into your calculator, 38 minus 6, let me grab my calculator here. And you divide that by 2.8, you'll get 10.5 as your answer. All right, question number 17, screens. Charlotte surveyed 420 chosen students at her school, asking how many hours they spent looking at a screen during the week. The average time spent was 24.8 hours, with a standard deviation of 3.9. Use a 95% confidence interval to find the maximum error of the estimate of time spent looking at a screen. Round your answer to the nearest hundredth. Okay, so let's highlight some information here. I see n equals 420. I see the mean here is 24.8. I see that the standard deviation of this sample is 3.9, and I see a 95% confidence interval. So if I look back at my notes, the first thing that I probably want to do here is write down a formula. To find the maximum error. This is E, or another way of saying is margin of error. So the formula is E equals Z times S divided by the square root of N. Okay. To get Z, you're going to have to use the 95% confidence interval is, you're going to get a Z-score of 1.960 from our notes. Okay, so I'm going to use this one for that value. So E equals 1.960. The S is 3.9. and the n value is 420. Don't forget the square root. And remember, to make this side a fraction, you just put it over 1. So essentially it is 1.960 times 3.9. I'm gonna take a picture and I'll do that with you so you can see that step by step. Okay, so go to my calculator. I'm gonna type in 1.960 times 3.9 divided by the square root, which is second, and then up here by the 7 is in orange, the square root 420. We'll press right key to get out and then close the parentheses. And that gives me an e value of 0.372, and it tells us round to the nearest hundred, so 0.372. 0.37. So we can say with 95% confidence that the mean time spent watching a screen per week is 0.37 hours of the sample mean time. So we're pretty close. A website asked 842 chosen viewers, so n equals 842, how many times they visited the site. The average number, so our average, if we needed it, x bar equals 2.8, and a standard deviation s equals 0.4. Use a 99% confidence interval to determine the maximum error. So this is, let's put it here in yellow, to determine the maximum error of an estimate. So what is your e value? And then it says estimate the population of the mean. Okay, so what we can do here is we're going to do the same thing. First thing I'm going to do is confidence interval, which is 99%, to a z-score. And if you look at your chart, that is 2.576. Z equals 2.576. And that was not to have any decimals right there. My pencil right now. Oh, that's why it's by an object. Okay. All right, the second thing I'm going to do is calculate E. Same formula from above. And remember our z-score we just figured out from the confidence interval. So I have E equals 2.576, and then my S value came from up here, 0.4. And then I'm going to divide that by the square root of n. So n is square root of 842. Take a picture. Remember the not cheating way is just calculate command. Second enter basically repeats everything, and then it might be just easier to put everything in there. If you don't want to do that, there's another way. Alpha, the green button, then y equals, and it says fraction there in green in the top left there, and I learned that from another student. N parentheses d, and then there you can put everything in the numerator. 2.576 times 0.4, and then second x squared 842, and remember it's red, so you have to press right, and we get 0.04. Doesn't tell us word around, so I'm just going to be safe. 0.036. 0.036. 0.036. Okay. All right, the third thing I need to do now is calculate the population mean. To calculate the population mean, I'm going to get plus or minus the E. So, that value will come from 2.8. So let's write that. Whoops. Okay, plus or minus E. So this value goes here. And basically that just means you split it, right? So the mean could have a range of 2.8 plus 0.036 or 2.8 minus 0.036. That means the mean should be between this value, so 2.8 plus 0.036. This will give you a bigger value. So 2.836 and 2.86 minus 0.036 gives you a smaller number, which we put on the left. And this is my answer.
The new all-purpose Inkman has arrived with all your favorite catchphrases like
It's time for game plans!
and capable of doing anything you need.
I use mine as a bookmark.
I use him to help teach my class.
It's time for game plans!
And for a limited time offer, you can get yourself a silly man too.